Welcome to our deep dive into SU high availability clusters. We're going to break down the SUSE Linux Enterprise High Availability Administration Guide, specifically Chapter 5.
Ah, yes.
This chapter focuses on configuration and administration basics.
Right.
So think of it as the control panel for keeping your critical systems up and running, even when things go wrong.
Exactly. Yeah, like when hardware or software fails.
It's all about building those resilient systems, right?
It is, absolutely.
Before we jump into the specifics, though,
Sure.
let's zoom out a bit and think about why high availability is so important in the first place.
Okay.
So imagine scenarios like a radio station that needs constant uptime,
Right.
or, an assembly line, where any disruption means a loss of revenue. What makes high availability clusters crucial in these situations?
Well, in those scenarios, downtime means, a direct hit to their finances
Oh,
or disruption of critical services.
yeah.
High availability clusters really step in to minimize that downtime. They make sure that things keep running smoothly even when individual components fail.
Uh-huh.
And they do this by having redundant systems that are ready to take over seamlessly.
That makes sense.
These clusters, by the way, are categorized into two main types, two-node and multi-node.
Okay.
Multi-node clusters, they usually have an odd number of nodes, for reasons we'll get into later.
Gotcha. Now, the document actually highlights some common use cases for these cluster types.
Right.
It mentions a two-node cluster in a single location.
Yes.
Can you elaborate on that a bit? Like, what are the advantages of that setup?
So a two-node cluster in a single location, it really focuses on keeping services up and running
Okay.
more than data redundancy. It's perfect for embedded systems
Uh-huh.
or applications where being up and running all the time is the top priority, even if it means potentially losing some data replication.
So it's about keeping the systems alive, even if some data is temporarily lost.
Exactly. That's the trade-off.
That's interesting. Now, moving on to the two-node clusters that are spread across two locations,
Right.
the document mentions those are the most popular.
Yeah, the most common for sure.
Why is that configuration so widely used?
Well, because they give you both.
Uh,
High availability and local data redundancy.
uh-huh.
So it's a good fit for applications like databases,
Yep.
ERP systems, anything where losing data is just not acceptable.
Makes sense.
If one site has an outage, the other one can take over.
Right.
And you still have a local copy of the data.
That's a great advantage. Now, the document also mentions multi-node clusters, but in 3 locations this time.
Yes.
Why would you choose to have 3 sites for your cluster?
Well, that third site acts as a tiebreaker, you could say,
Okay.
like a majority maker if there's a network split or if one site goes down.
Interesting.
Imagine one location going offline.
Uh-huh.
The other two, they can still form a quorum
Right.
and make decisions about what happens to the cluster. Keep things running. This is super important for preventing data corruption and maintaining consistency.
That makes a lot of sense. And that brings us to the concept of quorum, which seems to be at the heart of it all.
Absolutely.
So could you break down how quorum works
Yeah,
and why it's so vital in a cluster environment?
it is. Quorum is basically the minimum number of nodes that need to be working for the cluster to function properly. It's like imagine a voting system
Okay, yeah.
where the majority rules.
Uh-huh.
This prevents those, those split brain situations
Right.
where isolated parts of the cluster try to do their own thing,
Right.
which can lead to data getting messed up,
Right.
inconsistencies.
Yeah, that makes sense. Now, the document actually gives a formula for calculating quorum.
It does.
It's N is greater than or equal to C divided by 2 plus 1.
That's the one.
Can you break that down a bit?
Sure.
How does that formula relate to real-world cluster design?
Okay, so in that formula, N, that's the minimum number of nodes you need for a quorum.
Okay,
And C is the total number of nodes in the cluster.
got it.
So for example, if you have 5 nodes in your cluster, you would need at least 3 of them to be operational to maintain quorum.
Okay.
That formula helps you figure out how resilient your cluster needs to be.
Uh-huh.
For example, if your application absolutely needs to stay up, even if a whole site goes down, you'd need at least 3 sites to keep that quorum.
Right, so careful planning is essential to figure out the right number of nodes and sites.
Absolutely, from the get-go.
Now, the document highlights CoreSync as a key player for communication within the cluster.
It is.
What exactly does CoreSync do?
You could think of it as the nervous system of the cluster.
Okay.
It's a messaging layer that lets all the nodes talk to each other
Uh-huh.
and stay in sync.
I see.
And make sure that all the nodes have the same understanding of what's going on in the cluster, like who's a member, any changes that happen, that kind of stuff.
Huh. It's like the central communication hub keeping everything in order.
Exactly. Without it, the nodes, they'd be all over the place.
Right. They wouldn't be able to coordinate actions or make decisions together.
Exactly. Be chaos.
Now, the document mentions there are different ways to configure core sync for two-node versus multi-node clusters.
Right.
What are the key differences there?
Okay, so with two-node clusters, there's this setting, 2-node:1.
Got it.
And this basically streamlines decision-making because it's expecting only 2 votes.
I see.
It's faster, simpler.
Okay.
Multi-node clusters, on the other hand, they use the expected vote setting,
Right.
which obviously it depends on how many nodes you have in total.
Makes sense.
There's also this very important option called wait for all,
Okay.
which makes sure that all the nodes are actually online and ready before the cluster, goes live.
So two-node configurations are all about speed and simplicity,
Yeah,
while multi-node configurations are more about being thorough before going live.
it's exactly. Different needs, different approaches.
Right, because of their potential complexity.
Yeah.
Now let's shift gears a bit and talk about global cluster options. These are like the overall personality settings,
I
right?
would say that.
For the whole cluster. How it reacts in different situations. What are some of the key options that stand out to you?
Well, one of the most important ones is no quorum policy.
Okay.
And this basically dictates what happens if a cluster, if part of the cluster loses quorum.
Right.
It's like a contingency plan.
Gotcha.
The default setting is stop,
Okay.
which means that the affected part of the cluster will shut down all its resources,
I see.
gracefully, of course,
Okay.
to protect the data.
Right.
But there's also another option, freeze.
Okay.
And this one tries to keep the most important resources running, even if there's no quorum.
So it's like stop is hitting the brakes to prevent chaos,
Yeah.
and freeze is trying to limp along even when things are bad.
Exactly. It depends on, what you're trying to protect and the potential consequences.
Right, the application, the data, the whole context. Now, the other global option I wanted to touch on is Stoneth enabled.
Ah, yes. Stoneth.
It sounds a little intense.
It is. It stands for shoot the other node in the head.
Okay, that explains it. So it's like the cluster's way of dealing with a node that's misbehaving.
Exactly. Or if it's not responding.
It sounds a bit drastic.
It is, but it's crucial.
Yeah.
Think about it. If a node goes rogue or starts acting up, it could really mess things up, corrupt data.
Yeah, that makes sense.
Stoneth allows the cluster to basically force that node offline, like a safety measure.
So it's a last resort to protect the entire system from one bad actor.
Exactly. You got to keep the whole ship afloat, right?
Right. And the documentation is very clear about not disabling Stoneth.
They compare it to driving without a seatbelt.
What are the risks if you do disable it?
Well, you significantly increase the chances of, data getting corrupted, especially if a node has a hardware failure or gets disconnected from the network.
Okay.
If it keeps running on its own, it can wreak havoc, write bad data, make conflicting changes. The whole cluster could be compromised.
That's a risk you don't want to take, especially when dealing with critical systems and data. All right, let's move on to the tools that people actually use to manage these clusters.
Okay.
The document mentions Hawk2,
Yeah.
which is a web-based interface for administrators.
Yeah.
What are the key features of Hawk2 and what makes it so user-friendly?
It's basically a central dashboard
Okay.
where you can monitor and control your whole cluster. It gives you a real-time view of how each node is doing, what resources are being used, the status of different services.
So you can quickly spot any potential issues.
Exactly.
It's like having an overview of the entire operation right at your fingertips.
Exactly. And it also makes configuring things much easier.
Oh, how so?
It has these wizards, step-by-step guides for setting up things like virtual IP addresses, shared storage, even more complex setups like DRBD,
DRBD.
distributed replicated block device.
Okay.
It walks you through the process so you don't have to mess around with the command line.
That's a huge help, especially for administrators who aren't, command line gurus.
Exactly. It makes things much more approachable.
Now, the document also mentions something called batch mode in Hawk 2. What's that all about?
Batch mode is a fantastic feature.
Yep.
It lets you test out changes before you actually apply them to a live cluster.
So it's like a dress rehearsal for your cluster.
Exactly.
You can see how things will work without actually making the changes.
Exactly. You can test different configurations, see what impact they have, and spot any potential problems before they cause trouble.
Well, that sounds like a lifesaver. Now, for those who are more comfortable with the command line, the document highlights Crummerish as a powerful alternative.
Yes, Cremashy. It's a bit more hands-on,
Okay.
but it gives you a lot of flexibility.
So what are some of the key features of Crunch?
Well, it gives you direct access to all the cluster functions. You can use it interactively or create scripts to automate tasks.
I see.
It's a powerful tool for those who know what they're doing.
And speaking of automation, Crunch has this thing called cluster scripts.
Right.
What are those?
Think of them as um, pre-packaged sets of commands
Okay.
for common tasks like installing software, setting up resources, or gathering information from all the nodes.
I see.
They streamline the process so you don't have to manually do everything on each node.
So they're like a time saver.
Yes,
And they help prevent errors.
exactly.
The document emphasizes how flexible these scripts are.
Oh, absolutely.
Can you elaborate on that a bit?
You're not stuck with the default scripts. You can tweak them, add your own logic, and tailor them to your environment.
Right.
It's like having a template that you can customize.
That's really helpful. Now, the document also mentions a verification step before running these scripts.
Yes, a crucial step.
Why is that so important?
Before you run any script, Chromenex lets you verify it first.
Okay.
This checks the syntax, makes sure all the necessary resources are there, and looks for any conflicts.
Like a safety check before you launch something potentially dangerous.
Exactly.
That brings us to a feature that sounds really intriguing. Shadow configuration.
Ah, yeah, shadow configuration. It's like having a test environment for your cluster.
Okay.
You can create a separate configuration that mirrors your live cluster.
I see.
And you can experiment with new settings, play around with different resource configurations, see how things work without affecting the actual live system.
It's like a sandbox where you can experiment safely.
Exactly. It's a fantastic way to test out ideas and avoid making any mistakes on the live system.
And once you're happy with the changes you've made in the shadow configuration, you can merge them into the live one?
Yes, but it's a controlled process. Chromesh does a bunch of checks to make sure the changes won't cause any problems.
So it's not just a blind copy and paste?
No. It's a careful and controlled process to minimize the risk of any disruption.
That's reassuring. Speaking of testing and debugging, the document mentions a command called uptest.
Uptest is a great tool. It lets you simulate the effects of your configuration changes before you actually commit them to the cluster.
So you can see how the cluster would react without actually making the changes.
Exactly. You can identify any potential issues early on.
That's really valuable.
Absolutely. It can save you a lot of headaches down the line.
Now, the document mentions that uptest can generate diagrams.
Yes, these diagrams are incredibly helpful.
What kind of diagrams are they?
They visually represent the relationships between resources, constraints, and dependencies within your cluster configuration.
Okay.
They help you understand the complex interactions between different parts of the cluster, and they're really useful for troubleshooting.
It's like having a visual map of your cluster.
Exactly. It makes things much easier to understand.
Now, we've talked a lot about managing the cluster, but the messaging layer, ChorusSync, is also a critical piece of the puzzle.
It is. It's the backbone.
And the document indicates that you can use Chromesh to manage ChorusSync as well.
You can. Chromesh has a dedicated subcommand for ChorusSync.
So how does Chromesh interact with ChorusSync?
You can use it to check the status of ChorusSync, look at its configuration, compare configurations across different nodes, and even troubleshoot communication problems.
It's like having direct access to the cluster's communication system.
Exactly. You can really get under the hood and see what's going on.
Now, the document mentions a feature in Chromesh for managing sensitive information, like passwords.
Right. Security is crucial.
Can you explain how that works and why it's so important?
Instead of putting passwords directly in configuration files, you can use the QARM resource secret command.
Okay,
It encrypts the passwords and stores them securely.
I see.
So they're not just sitting out in the open for anyone to see.
That's a huge security benefit.
Absolutely. It helps protect your cluster from unauthorized access.
Now, we've covered a lot of ground in terms of managing and configuring the cluster, but we haven't really dug into how Stoneth, that emergency brake for misbehaving nodes, actually works in practice.
Right.
The document mentions something called fencing. Can you shed some light on that?
Fencing is the mechanism that Stoneth uses to isolate a problem node.
Okay.
It basically separates that node from the rest of the cluster, either physically or logically.
So it's like putting up a barrier to contain a potential threat.
Exactly. You want to prevent that node from causing more damage or corrupting data.
Can you give some examples of how fencing is implemented in real-world scenarios?
Sure. One common method is power fencing.
Okay.
It uses intelligent power distribution units, PDUs for short, to cut off the power to the problematic node.
So it's like hitting the power button remotely?
Essentially, yes. It takes the node offline.
And are there other methods besides power fencing?
Yes, there's network fencing. It uses network switches to block the node's access to the network.
So it's like cutting off its communication lines.
Exactly. It can't talk to other nodes or access shared resources.
That's clever. Are there any other fencing techniques used in SESC's cluster?
Yes, storage fencing is another option.
Okay.
It uses storage area network, SN, commands to block the node's access to shared storage devices.
So it can't read or write data.
Exactly. This is really useful for protecting data in situations where the node might still have network access.
It's like cutting off its access to the data itself. That sounds really comprehensive.
It is. It's all about protecting the integrity of the cluster.
Right. Now, we've talked a lot about quorum and how important it is to have a majority of nodes operational.
Yes.
But what happens if a cluster actually loses quorum?
Uh-oh. That's not good. It means the cluster can't make consistent decisions anymore.
Okay.
Depending on that no quorum policy setting we talked about earlier, it will either shut everything down or try to keep the essential services running.
So it's a critical situation. How does the cluster recover from that?
Well, you need to figure out what caused the quorum loss in the first place and fix it.
Right.
Maybe some nodes went down or there's a network problem. Once you fix that, the cluster can usually come back online.
So it's all about restoring that majority, that critical mass of operational nodes.
Exactly.
Now, you mentioned earlier that multi-node clusters typically have an odd number of nodes.
Right.
What's the reason for that?
It's all about avoiding those split brain scenarios we talked about.
Right.
If the cluster gets split into two groups because of a network problem, having an odd number of nodes ensures that only one group can have a majority.
I see.
So only one group can make decisions, which helps prevent data corruption.
So it's a simple mathematical trick to prevent chaos.
Exactly. It's all about careful planning and design.
Right. And it highlights how every aspect of these high availability clusters is designed for resilience. We've covered a lot of ground today, from the basic concepts to the tools and techniques used to manage these complex systems.
We have. It's been quite a journey.
What are some of the key takeaways you'd want our listeners to remember as they explore the world of SUSE high availability clusters?
Well, I think the most important thing is to remember that high availability is not just about technology. It's about understanding what your business needs are and how critical your applications and data are.
Right.
Building a resilient system takes planning, understanding the different components, and choosing the right tools for the job.
So it's about aligning the technology with the business goals. We've been talking a lot about the SEO Linux Enterprise High Availability Administration Guide, specifically Chapter 5.
A great resource.
What makes this document so valuable for anyone working with or interested in high availability clusters?
It's a really comprehensive guide. It covers everything from the basics to the advanced stuff. It's got practical examples and step-by-step instructions that can help anyone, from beginners to experts.
So it's a resource that can grow with you as you learn more.
Exactly. And there's always more to learn.
That's true. Now, as we wrap up this deep dive, what's one thought-provoking question you would leave our listeners with? Something to ponder as they continue their exploration of high availability clusters.
Well, we talked about STONIF, those extreme measures to protect data. So I'd ask, how far would you go to protect your data in a crisis? What trade-offs would you be willing to make?
That's a great question. It makes us think about the value of data and the difficult choices we might have to make.
Exactly. It's not always a simple answer.
Well, thank you for joining us on this deep dive into SUSE high availability clusters. We hope you've gained valuable insights into how these systems work and the things you need to consider when building one.
It's been a pleasure. Remember, high availability is not just a technical concept. It's a mindset. It's about making sure the systems we rely on are always there when we need them. It's a mindset, a commitment to keeping those critical services up and running, no matter what.
Absolutely. And it seems like every aspect of these clusters is designed with redundancy and resilience in mind.
Oh, definitely. From the ground up.
We've covered a lot of ground today, from the core concepts like quorum and fencing to the practical tools like HOC2 and Krmish that people use to manage these systems.
It's a lot to take in, for sure.
What are some key takeaways you would highlight for our listeners as they delve deeper into this world of SUSE high availability clusters?
I think the most important takeaway is that high availability isn't just about the technology itself. It's about understanding the business needs,
Right.
how critical are the applications and data you're trying to protect. Building a truly resilient system takes planning, understanding all the different pieces, and choosing the right tools for the job.
That's a crucial point. It's about aligning the technology with the business objectives. We've been talking a lot about the SESC Linux Enterprise High Availability Administration Guide, specifically Chapter 5.
It's a great starting point.
What makes this document so valuable for anyone working with or interested in high availability clusters?
Well, it's really comprehensive. It covers everything from the basics to the more advanced features. It's got practical examples, step-by-step instructions. It can help anyone, whether you're just starting out or you're a seasoned admin.
So it's a resource that can grow with you as you learn more.
Exactly. And there's always more to learn in this field.
That's for sure. Now, as we wrap up this deep dive, what's one final thought-provoking question you'd leave our listeners with? Something for them to ponder as they continue their exploration of high availability clusters.
We talked about Stoneth, those kind of extreme measures to protect data integrity. So I'd ask, how far would you go to protect your data in a crisis? What trade-offs would you be willing to make between availability, consistency, and data integrity? It's a question that really gets to the heart of how important data is today.
That's a great question. It forces us to think beyond the technical stuff and consider the broader implications of data resilience.
Exactly. It's not always a black and white answer.
Well, thank you for joining us on this deep dive into high availability clusters. We hope you've gained some valuable insights into how these systems work and the things you need to think about when building one.
It's been my pleasure. And remember, high availability is not just a technical concept, it's a mindset, a commitment to ensuring that the systems we depend on are always there when we need them. It really is. It's about peace of mind, knowing your systems are going to be there when you need them.
Absolutely. And knowing how to make sure of that, right? We've talked a lot about the technical side of things today.
Yeah, we've gone pretty deep.
But for someone who's just starting to learn about high availability clusters, what would you say are the most important things to keep in mind?
Well, I think the first thing is don't get overwhelmed. It can seem complicated at first. There's a lot of moving parts. But the basic concepts, they're not that hard to grasp.
Right. It's about building a solid foundation.
Exactly. Start with the basics. Quorum, fencing, those sorts of things. Once you have a good handle on those, the rest starts to fall into place.
And there are great resources out there to help people learn.
Oh yeah, for sure. The SUSE documentation we've been talking about is a great place to start. It's very thorough.
And it's free, right?
Yes, it's freely available online. You can download it, read it at your own pace.
That's fantastic. Now, we talked about Hawk 2 and Kremesh. Are those the only tools people use to manage these clusters?
Those are the main ones from SU, the ones that come with the package. But there are other tools out there. Open source tools, commercial tools. It really depends on your needs and your budget.
So it's a bit like a toolbox. You can choose the tools that work best for you.
Exactly. And don't be afraid to experiment. Try different things out. See what fits your workflow.
That's great advice. Now, before we wrap up, I have one last question for you. It's a bit philosophical, maybe.
Okay, shoot.
We've talked a lot about preventing failures, making systems resilient, but failures are inevitable, right?
Oh, absolutely.
Yeah.
No system is perfect. Something will eventually fail.
So how do you deal with that reality? How do you prepare for the unknown?
That's a great question. I think it's about accepting that failures will happen and building systems that can gracefully handle them. It's about having backups, redundancy, and a plan for when things go wrong. It's also about being able to learn from those failures and make your systems even stronger.
So it's about constant improvement, always striving for better resilience.
Exactly. It's a journey, not a destination.
That's a great way to put it. Well, thank you so much for joining us on this deep dive into SUSE high availability clusters. It's been a fascinating conversation.
My pleasure. I always enjoy talking about this stuff.
And thanks to our listeners for tuning in. We hope you found this deep dive informative and engaging. Until next time, keep exploring and keep learning.